Welcome back to another Circuit Basics video tutorial. I'm Scott, and today I'd like to show you how to set up an LCD on the Raspberry Pi and program it with C. I did another video on how to set up and program an LCD with Python, so with these two videos you should be able to pretty much incorporate an LCD into almost any Raspberry Pi project. I'll be using a C module called WiringPi to program the LCD. WiringPi comes with a basic set of functions for controlling text on the LCD, but using them can be a little confusing if you aren't familiar with C programming. So first I'll show you how to connect the LCD to the Pi. Then I'll go step by step through all the different things you can do with the LCD. I'll show you how to do basic stuff like positioning text, turning on and off the cursor, and printing the date, time, and IP address. Then I'll show you how to do more interesting stuff like scrolling, creating custom characters, and displaying data from a sensor. So let's get started. I've got my Raspberry Pi and a breadboard here. I'm going to insert my LCD into the breadboard. Now I'll insert a 10k ohm potentiometer for the contrast, and another 10k ohm potentiometer for the backlight brightness. Now I'll connect the VSS pin of the LCD to the negative rail of the breadboard. Then I'll connect the VDD pin of the LCD to the positive rail of the breadboard. Now I'll connect the VO pin of the LCD to the center pin of the contrast potentiometer. Then I'll connect the RS pin of the LCD over to pin 37 on the Pi. All the pin numbers I'll be referring to are the pin numbers on the board. Next, I'll connect the RW pin of the LCD over to the negative rail of the breadboard. Then the E pin of the LCD over to pin 35 of the Raspberry Pi. First, I'll connect the LCD in 8-bit mode, and in a minute I'll show you how to connect it in 4-bit mode. For 8-bit mode, I'm going to use a 4-wire ribbon cable and insert it into the breadboard at the LCD data pins D0 to D3. Then I'll connect that to the pins on the Pi, with LCD pin D0 connecting to pin 40 of the Pi, LCD pin D1 to pin 38 of the Pi, LCD pin D2 connecting to pin 36 of the Pi, and LCD pin D3 connecting to pin 32 of the Pi. Now I'll use another 4-wire ribbon cable to connect the data pin D4 of the LCD to pin 33 of the Pi, LCD pin D5 to pin 31 of the Pi, LCD pin D6 to pin 29 of the Pi, and LCD pin D7 to pin 23 of the Pi. Now I'm going to connect the A pin, the second to the last pin on the LCD, to the center pin of the backlight brightness potentiometer. I'll connect one of the outer pins of the backlight brightness potentiometer to the positive rail of the breadboard. It doesn't matter which side is connected, it only changes which direction turns the knob, increase and decrease the backlight brightness. Next I'll take a jumper wire and connect one side of the contrast potentiometer to the negative rail of the breadboard. Now I'll take another jumper wire and connect the K pin, the last pin of the LCD, to the ground rail of the breadboard. Then I'll connect the negative rail of the breadboard to the ground pin of the Pi, pin 6. Now I'll connect the positive rail of the breadboard to the 5-volt pin of the Raspberry Pi, pin 2. And the LCD lights up. I'll just adjust the contrast. And the backlight brightness. Okay, there we go. Alright, as I said earlier, we'll be using the functions in WiringPi to control the LCD. So in case you don't have it installed already, I'm going to show you how to do it. I'm going to assume you've already established an SSH connection or some other way to access the command prompt. I use PuTTY, so I'll just log in here. And in order to download WiringPi, we need to install Git. If you don't have Git already, just enter sudo apt-get install git-core. If you get any errors here, try running sudo apt-get update and then try it again. Now we can download the WiringPi files with git clone git:/git.drogon.net/WiringPi. Now change directories with cd WiringPi and enter ./build to install it. And we can make sure everything installed correctly by entering gpio-v and gpio readall. Okay, looks like everything's installed correctly. You can enter cd to get back to the root directory. I'm going to link to this post in the description so you can copy the code I'll be using to demonstrate the LCD functions. There's also all the wiring diagrams, instructions for installing WiringPi, and the example programs I'll be using. Okay, since we connected the LCD in 8-bit mode, here's a program that will print Hello World to the LCD in 8-bit mode. I'll just copy this. And we're working in C here, so I'll create a file called example.c. Right-click to paste that code in there. Save and exit. WiringPi gives us several options to configure in the initialization function. I'm using a 16x2 LCD, but you can use other sizes too. Just change the row and column numbers in the LCD init function here. And we're doing 8-bit mode now, so the 8-bit mode is set at 8. These initialize the RS, E, and data pins. Up here you can change the pin numbers for any of the LCD connections to your Pi. And the numbers here are WiringPi pin numbers. Just do a quick search on the internet to find out how to convert the WiringPi pin numbers to the pin numbers on the board of the Pi. Also, if you're not familiar with writing and running C programs, we'll need to compile the code after each time we change it. C programs using WiringPi can be compiled with this command right here. So that will compile our 8-bit Hello World program. Then we can run the program with sudo./example. There you go, Hello World. Okay, it's pretty clear that 8-bit mode takes up a lot of GPIO pins. That's why most people will probably want to use 4-bit mode. Here's the same Hello World program in 4-bit mode. Only 4 data pins are defined. LCD data pins D4 to D7. Data pins D0 to D3 aren't used in 4-bit mode, so we can just disconnect them. In the initialization function, we just have zeros where the 4 extra pins for 8-bit mode would be. And then we've changed the bit mode number from 8 to 4. So let me copy this. Instead of retyping all these commands, in PuTTY you can use the up and down arrows to scroll through previous commands. Use Ctrl K to cut out this old code, and right click to paste the new code in there. Compile it, and run it. So here you go, Hello World in 4-bit mode. Looks pretty similar to Hello World in 8-bit mode, but it uses 4 less wires, so that's good. The function LCD puts is what prints the text to the LCD display. By default, text is positioned starting at the top row, second column. But we can change the position of the text with the LCD position function. The first number inside the parentheses is the column position, numbered 0 to 15. And the second number here is the row position, numbered 0 to 1. So 3, 1 will position the text on the bottom row, 4th column. Let me just copy this. Compile it, and run it. So there you go. Hello World is printed to the bottom row, 4th column. To clear the screen, you can use the LCD clear function. This program will print the first half of the sentence for 2 seconds, clear the screen, then print the second half for 2 seconds, and clear the screen again. The LCD clear function positions the cursor at the top row, first column. Notice how the first half of the sentence is printed to the default top row, second column position. Then, after clearing the screen, the second half of the sentence prints to the top row, first column. Using the LCD puts function together with the LCD clear function in a while loop, we can create a blinking text effect. In order to avoid positioning the first hello world of the loop at the second column, we need to use LCD position to position the text at the first column. Then we print hello world, wait 2 seconds, clear the screen, wait another 2 seconds, then loop back up to the top to do it again. Let's see what this looks like on the LCD. Okay, cool. It's getting a little more interesting. Now let's look at how to use the cursor. You can have an underline non-blinking cursor, an underline blinking cursor, or a blinking block style cursor. Just use these functions right here, and the cursor will be placed after the last character in your text string. Let's take a look. This line will make an underlined non-blinking cursor. See the underline cursor after the exclamation point in Hello World? Let's try the blinking block style cursor. I'll just comment this out and uncomment this line. There we go, a blinking block style cursor. Now to get a blinking underline cursor, we need 2 lines of code. Let me comment this out and uncomment these two lines. There we go, a blinking underline cursor. Here's a program that will print the date and time to your LCD. This can be useful for lots of different projects. I'll just copy this. Paste it in there. Compile and run. There we go. March 23rd, 2016 at 18:52. Pressing Ctrl-C will exit the program. Here's a program that will print the IP address of your Pi. This is the IP address of my Ethernet connection. You can also get the IP of your Wi-Fi connection. Just come down here to line 30 and change the ETH0 to WLAN 0. There it is, 10.0.0.24. Okay, now on to custom characters. Each character on the LCD is a grid of 5x8 pixels, and you can make any pattern inside of that grid and print it to the screen as a custom character. Up to 8 custom characters can be defined and stored in the LCD's memory at one time. I have a link to a website here that will generate the code we need to define the custom characters. This is the part we need right here. And that goes right here, where we define the custom character and give it a name. In this case, we'll be printing the Greek letter omega, so I've named it omega. After we define the character, we use the LCD char def function to tell the LCD to store that character in its memory. The number 2 here refers to the location in the LCD memory, and we also need to have the same name we use to define the character in here. Then to write the character to the display, use LCD put char with the memory location of the character in parentheses. In this case, it's 2. So let's see what this looks like. Alright, there's the omega printed to the display. So that's a single custom character. What if you want to print multiple different custom characters? As I said earlier, you can define up to 8 different characters at a time. Just give each one a different name and define them like this. To load the characters in the LCD memory, use the LCD char def function as before, but use a different memory location for each one, followed by the name you gave it in the definition above. Here I have 5 different characters, the Greek letters omega, pi, and mu, and a symbol for a water drop and a thermometer. I've used the numbers 10, 11, 12, 13, and 14 to store them in the LCD memory. Now to print the characters, use the LCD put char function with the memory number you gave each character in the parentheses, 10, 11, 12, 13, and 14. So let's see what this looks like. There you go, omega, pi, and mu with symbols for humidity and temperature. Scrolling text is really useful. If you have a lot of data to display, or if you have a text string that's longer than the column length of your LCD, you can always scroll it into the screen. This program will scroll text onto the screen from right to left, then pause, clear the screen, and start over again. I wasn't able to find a good way to scroll text on and off the screen in an infinite loop, but if you figured out a way to do that, let us know in the comments, because I'm sure a lot of people would like to know. This program does pretty much the same thing, but from the left side to the right side. Alright, one of the most useful things you can do with an LCD is use it to display sensor data. I'll demonstrate how to do this with the DHT11 humidity and temperature sensor, but this will work with any sensor. Instead of printing the sensor data to the screen with the LCD puts function, use the LCD printf function, with the variable for your sensor reading inside the parentheses. Let me just show you how to connect the DHT11 real quick. Connect the 5-volt pin of the DHT11 to the positive rail of the breadboard. The negative pin of the DHT11 to the negative rail of the breadboard. And the signal pin of the DHT11 to pin 7 of the Pi. So let's see what this looks like. Okay, there we go. If you want to change the temperature to Celsius, scroll down to line 72, uncomment that, and comment out line 73. See, here are the LCD printf functions, with the variables for humidity and temperature inside the parentheses. Alright, there we go. Well, that's pretty much about it. Hope you found this video helpful. If you enjoyed it, please like it and subscribe to our channel. We want to reach as many people as possible, so if you know anyone that would like it too, just tell them about it. Alright, we'll talk to you next time. Bye-bye.